Good morning students. In the last class we have discussed about time shifting operation with one continuous time signal, and in this class we are going to discuss about the time shifting operation with discrete time signal. Okay, so for time shifting operation there is no difference rule for continuous time and discrete time signal. Just for better clarification I am going to explain with one discrete time signal. Okay, whereas in time scaling operation rule is the same, but we have to be careful while doing the time scaling for discrete time signal. So that I will explain while discussing about time scaling operation. So as of time shifting operation the rule is same. Okay, so for this question they are given x of n and we have to sketch the following signals, that is x of n plus 3, x of n minus 2, x of minus n plus 1, x of minus n minus 1. Okay, so as we discussed in the last class, for shifting of original signal, that is normal signal x of n, okay, we have to perform the inverse operation, that is here x of n plus 3 means we have to subtract 3 with the limits. Okay, and n minus 2 means we have to add 2 with the limits. Okay, so whereas the rule is reversed for reverse signal. Okay, that is x of minus n plus 1. So for this we have to plot first x of minus n and then do the same operation, that is plus 1 means we have to add plus 1 with the limit, that is limit of x of minus n. Okay, also for x of minus n minus 1 also we have to plot x of minus n first and then we have to subtract 1 with the limits. Okay, so we will plot one by one. So first we will plot x of n plus 3. Okay, so n plus 3 means we have to subtract 3 with the limits. Okay, so if we subtract, what we will get? So here minus 2, so minus 2 minus 3, minus 2 minus 3 minus 5. So the first, so it's enough. We will, if you check with the first and last point, because in the shifting operation we have to move the entire signal. So without changing the shape, amplitude, we are going to just moving the signal towards right side or left side. Okay, so it is enough if you we will calculate the first limit and the last limit. Okay, so it's n plus 3, so we have to subtract by 3. So minus 2 minus 3, it's minus 5, and 2 minus 3, it's minus 1. Okay, so we can draw x of n plus 3 minus 5 n, this is minus n, x of n plus 3, so amplitude 1 2. Okay, so this signal is just I'm going to shift towards left side. Okay, the signal present at minus 2 will move to minus 5. Okay, so at minus 5 the value is 1 and 1, at 0 and 1 this value is 2, and n. Okay, the same signal I am dragging towards left side by the samples 3. Okay, so the initial point is from minus 2 to minus 5, and the last point will move from 2 to minus 1. Okay, so this is x of n plus 3. Okay, and second case, x of n minus 2. So it's minus 2. So minus 2 means we have to add. Okay, so this first point is minus 2, minus 2 plus 2, 0, and the last value plus 2. So plus 2 plus 2, 4. Okay, so this will give delayed signal by the sample 2. So instead of minus 2, this signal is going to start at 0 and n with 4. Okay, so we can draw x of minus 2 n minus 2 so at 0 the value present at n equal to minus 2 will move to 0. Okay, so at 0 its value is 1. So we will get signal like this. That is the entire signal we are dragging towards right side by the sample 2. Okay, so we will get delayed signal. Okay, so this is advanced signal and this is delayed signal. Okay, so next we will draw third one, x of minus n plus 1. So for that first we have to plot x of minus n. Okay, so x of minus n is, so the signal start from minus 2 to plus 2, so the limit will be again minus 2 to plus 2 only. Okay, but the absolute value we have to be conscious. Okay, so x of minus n, at 0 it won't be changed, so at 0 its value is 2, so it's 2. Minus n, the signal present at n equal to minus 2 will move to n equal to plus 2 and n equal to minus 1 will move to plus 1, 0 is same, and plus 1 will move to minus 1 and plus 2 will move to minus 2. This is x of minus n. Okay, so after that we have to perform x of minus n plus 1. So minus n plus 1 means it's the reversed signal. For reversed signal we have to perform the same operation, that is we have to add 1 with the limits. Okay, so the first value minus 2 plus 1 minus 1, the last one 2 plus 1 3. Okay, so that is, so instead of minus 2 to plus 2, the signal is going to shift towards left side by the sample 1. Okay, the new limits are minus 1 to 3. Okay, so we will get x of minus n plus 1, like the new limits are minus 1 2, minus 1 0 1 2 3. So amplitudes are same, so so we are going to just shift the, so now we have to refer x of minus n. So students mostly do the mistakes here, that is they will draw the x of minus n, but while shifting they are considering x of n. Okay, so here we have to be careful. So first we have to plot x of minus n and then we have to shift the signal x of minus n. Okay, so at n equal to minus 2 is 1, so this value will move to n equal to minus 1 and then okay, so this signal I am going to drag towards right side by the sample 1. Okay, so while comparing with the original signal we will get delayed signal by the sample 1, because the original signal, the signal start at minus 2, so in x of minus n plus 1 will, the signal start at n equal to minus 1, so we will get delayed signal. Okay, and fourth case, x of minus n minus 1. Okay, so for this case also we have to plot x of minus n first. Okay, so already we have plotted x of minus n, that's why I didn't plot it again. Okay, for x of minus n minus 1, we have to subtract with 1 because here minus n minus 1. Okay, so minus 2 minus 1 minus 3, and last limit 2 minus 1, it's 1. Okay, so in the new signal limits from minus 3 to plus 1. Okay, so we are going to drag the signal towards left side by the sample 1. Okay, so the signal start from minus 3 instead of minus 2. Okay, so we can draw x of minus n minus 1 like 1. The same signal I am going to drag towards left side. So the value present at minus 2 will be moved to minus 3. And next two values are 2 and then okay. So this is x of minus n minus 1. This is delayed signal, sorry, advanced signal, because instead of minus 2 the signal start early by one sample. This is advanced signal. Okay, that is for x of minus n minus 1 we have to subtract 1 with the limits of x of minus n. Okay, so minus 2 minus 1 minus 3, 2 minus 1 1. Okay, so the limit from minus 3 to 1, that is we are going to drag the signal towards left side by the sample 1. So it is starting with minus 3 instead of minus 2, so it's a advanced signal. Okay, so in the next class we will see about time scaling operation. Thank you.